again, and in today's discussion, we are going to understand time complexity analysis. That's a very important uh, topic in DSA. We must all understand the importance of it. So basically, this is like how much time an algorithm use for certain input. We denote time complexity by O, and we pass some function there where, as you can see on the screen, that these three dots represent some function. Um, for example, I have specified is that O of n is the time complexity of an array with some inputs, and the array is of size n. Okay, so I want to give you some different examples how this time complexity analysis changes for different code. So suppose if we have a for loop that is just starting from 1 to n, and we have certain logic inside it, then the time complexity for that is O of n. Suppose if we have nested for loops, uh, the first one is starting from 1 to n, and the second one starting from 1 to n, but it is nested inside another loop. So the time complexity will be n square. Okay. Another example is order of magnitude. Suppose you have a for loop and you have the limiting condition as 3 into n, actually 3n. So then the time complexity will changes to O of 3n. And we have another example where we have multiple variables. First loop is ending by n and another loop is ending by m, and it is nested. So we represent time complexity as O of n into m. So the next example is when we have multiple phases, like we have continuous lines of code. So we have first for loop that has 3 into n, uh, 3n basically. Then we have another nested for loop. So here you have to split the complexity in multiple phases. First is O of 3n, and second is O of n square. So we have another example that we have already discussed, as we have multiple variables there, uh, n into m. So time complexity can also be categorized into multiple classes. If algorithm does not depend on the input size, then it is O of 1. If algorithm has an input size at each step, then it is falling under category of log n. If an algorithm solution lies somewhere in the middle, then it is n square root. And uh, if the algorithm goes through the input constant number of times, then we have O of n. If algorithm sorts the inputs, then n log n. If algorithm has nested loops, n square. If algorithm iterates through all the permutation of inputs, then we can say it's n factorial. So now also we need to understand by calculating time complexity, like if you're already aware of the kind of input size, for example n here, if n is less than 10, or if n is less than equals to 20, or n is very large, so we can bracket the time complexity in these categories. So for less than 10 is n factorial, less than 20 2 raised to power n. If n is large, it could be O of 1 or O of log n. So with all this information, it helps us uh, quickly estimate the time complexity without even writing the code on the program. So it helps you uh, make possible predictions how efficient is your solution is. So we will be looking at next some examples in the next video, and I hope you like it. Thanks for watching.